Hello again, and welcome to Investigation 3, Part 2. And on this section, we are actually going to look at making an electromagnet. So in order to do this, we're going to take a look at our old friend, the rivet. And we're going to discuss this a little more in detail. On the very top of the rivet up here is the rivet head. It looks like the bigger piece, the thicker piece that's up on the top, like the head of a nail or the head of a screw. And the rivet also does contain some washers, and those are the black pieces that you see here. So there are 3 washers on this picture, and they're made out of plastic or rubber, depending on what this one is composed of. So what they're going to do first is you take that yellow wire and wrap it around the rivet 40 times. Now it must be wrapped very tightly in order to fit 40 wraps around, because this already has 1, 2, 3, 4, 5, 6, 7, and you can see how much room that takes. So you need 40 wraps is a lot of time you need to spend around, and it's a lot of space it takes. So they need to be wrapped and pushed together very tightly in order to fit that. Well, fast forward, they've got the 40 wires wrapped around now. Now we go back to the circuits that we worked on during the last part of this experiment, when you guys made all those circuits online and learned how to put them together and to see what worked and what did not work. So in order to create our electromagnet, we are going to use the following pieces. We have a D-cell battery holder, which is on the right side of the screen. It is blue. It has 2 little coiled wires coming out of each end of it, and it does contain the battery already. We have a switch, which is on the top left. It's towards the middle of the screen, but it's on the left on the top. And that switch is open right now. When that switch is open, it means it is not conducting electricity. If that switch were closed, it would mean it was conducting electricity. Okay, so right now that is in the up position, so it is not conducting electricity. And then we have connections with the wires. We have the yellow wires sticking out that connect our rivet to the battery, the other end of the battery to the open switch, and the other end of the open switch back to the rivet. So this does make a complete circuit. Right now the circuit is not complete because the switch is in the up position, but if we were to close the switch, then this would be a complete circuit. So now we're going to find out what happens if we close this switch and turn this into a circuit. Okay, so here we have added paper clips to our project. The switch will be closed, and our rivet is suddenly picking up paper clips. As soon as that switch is opened again, the rivet will drop the paper clips. Close the switch, it picks up the paper clips. Open the switch, they fall instantly. So what we essentially just did is turn that into a temporary magnet. It is called an electromagnet because we're adding electricity into it in order to make it a magnet. So what details of the design are important to get the electromagnet working? What is going to be important to get that electromagnet working? Because that rivet was not magnetized before, and now it is. And what does wrapping the wire around the core accomplish? So we'll take a look at those questions when we head back to our Nearpod, and I'll see you in a few minutes.